So once again, good morning, students. And now we are starting the most important part and most awaited part. And the part is object-oriented programming. In short, it is OOPS. And we are starting in Java programming language. So there are different paradigms. Actually, there are different programming languages. We have seen, different programming languages in our previous sessions. For example, we have seen the most common programming language. What we have seen is C, and we have also seen C++. And then we have seen some of the interpreting languages also. For example, we have seen Python, and we have seen one program in JavaScript also. So there are different, students, programming languages exist for the development and for the application development. But each programming language follows a different paradigm. And what is a paradigm? It's a strategy. It's a methodology. It's you can say a kind of a framework which follows. For example, C follows, and somehow C++ also follows procedural oriented programming language paradigm. So in procedural, we are focused on functions. So every program is divided into different modules, and those modules are sometimes known as functions or subroutines also. And there are other paradigms also. For example, functional programming language, functional programming paradigm. Functional, what is a functional programming paradigm? In this kind of a programming paradigm, the programs are written as a mathematical functions. Okay, as a mathematical function. And the example is that this Python, if you like, Python follows a different paradigm, and one of the paradigm is functional programming paradigm. Likewise, we have other paradigms also. For example, declarative programming languages, imperative programming languages. So forget about everything. Now we are focused on what something called, which is most important, is object-oriented programming paradigm. Object-oriented programming paradigm. Okay, just in summary, every language follows some kind of a paradigm. So C and C++ mostly follows procedural, although C++ is object oriented also, but mostly they follow procedural paradigm. Python follows different paradigm. One of the paradigm is functional, one of the paradigm is procedural, and one of the paradigm is OOPS also. But as far as Java, students, as far as Java is concerned, Java is purely, you can say, purely object oriented programming. That's why it is very specific, and it is very interesting also. It makes very interesting, and it makes very clear cut style of a programming also. So object oriented programming, if you like, it's literally a very powerful programming paradigm that helps organize and structure code by modeling a real world entities as objects, because one of the thing in object oriented programming is object. So in this paradigm, actually, the real world entities are modeled as what? Objects. That we have to learn, and it is a key approach in modern software development. It is one of the you would say in application development, especially in server side application development, and even in a mobile application development, it is one of the key approach enabling better. The advantages are code reusability and maintainability, and also the scalabilities, because the current applications, they require scalable solution. I hope everybody understand that when the application, we have to extend the application in terms of user, in terms of server, in terms of capacity, in terms of you can say a space complexity or time complexity, in many aspects. Actually, mostly it is a users only. So we would say that this process, we say it scalability. So object oriented programming supports in scalable solutions, and of course the maintainability will becomes very easy, and of course the code reusability is one of the key feature of object oriented programming. Then object oriented programming encourages modular design. Modular design, in a sense, your project is divided into parts. For example, P1, P2, and P3. P3. So your project or your application can be divided into modules, okay, and these modules can be developed independently, and you can integrate those modules into one application, and that application will work absolutely fine. And in this case, it becomes very easier to collaborate on the projects and the management of the complex system, because we are dividing into modules. Everything you will understand. I'm just giving a just an overview what kind of a programming uh, uh, we are going to start in Java, especially as far as the object-oriented programming is concerned. Then deeply, the object-oriented principles are deeply ingrained, making it a perfect choice for learning and applying OOPS concepts. So our main objective is actually we are learning two things at a time. Obviously, two things at a time. One thing is this object-oriented paradigm, and obviously the next thing is what we are learning is Java. So through Java, what we are learning is object-oriented programming. So in this one, you can say a course, or in this one you can say a syllabus, you will cover two things. One is object-oriented programming and another is Java. Then object-oriented programming paradigm focuses on modeling software as a collection of what objects that interact with each other. So you will be having different objects, for example O1, O2 and O3. There would be a different objects in your applications, and they would be communicating with each other. They would be communicating with each other, and that's the way your application may become interactive, and a lot of other advantages you would see. Object represents a real world entities, concepts or things, and they encapsulates both data, I mean the attributes and the behavior. Okay, I'm going mostly in a theoretical way, but just note it down somewhere, these terminologies. For example, the first terminology is itself object oriented programming. Then you have this object, and what is object? It's a real world entities. So another word I'm introducing is entity. Then concepts also, or you can say a thing also. So all of these things are representing what? Objects, and they encapsulate. Another term is encapsulation. So just try to ingrain, or just try to keep in your mind these terms, because these terms are very handy, and throughout the course we are learning these terms, so it won't be a problem, I hope. But just for today's, keep it in mind, these different terms. Okay, then most important thing, I always start this object-oriented programming from this heading, and this heading is very necessary. For every concept or for every framework and for every model, there are some core pillars, or there are some core concepts, or you can say there are some core fundamentals, and on the basis of those fundamentals, you build your methodology. So as far as object-oriented programming is concerned, we have four important pillars. Four important pillars, and the object-oriented programming paradigm is resting on these four pillars. So first pillar is encapsulation. Second pillar is abstraction. Third pillar is inheritance, and the fourth pillar is polymorphism. I hope many of you have already heard about these terms, but now we are starting officially, and now we are starting formally the four you know terms in object oriented programming, or four pillars of object oriented programming. So one of the first pillar is what? Encapsulation. And in Java, these four pillars, I would say this way, these four pillars are implemented in Java, because I said Java is purely object oriented programming. So any program you are writing, it will follow object oriented concepts only. It will never follow the procedural the paradigm, or it will never follow the functional paradigm. Rather, it will follow only and only object oriented paradigm. So in Java, encapsulation is implemented through class and objects. Okay, encapsulation is a concept. Encapsulation is a first pillar. And in Java, it is implemented through class and objects. And what is abstraction? We'll understand what is abstraction, and we'll understand each and everything. Abstraction is implemented through access specifiers. Access specifiers. And just for your information, there are three access specifiers: public, private, and protected. Then inheritance in Java is implemented by this thing called extending a class. And when you are extending a class, two things are required. One is called a base class, and another is called a drive class. Drive class. Yes, and then polymorphism. Polymorphism is implemented through virtual functions and overriding. Virtual functions and overriding. So what we need to understand, we'll start from the encapsulation part. We have to understand first the meaning of encapsulation, and then class and objects we have to understand from a different perspective. So let me give you some a basic overview once again of the encapsulation part. It is most important pillar of object oriented programming. It is a first pillar in OOPS, and it is the most important pillar in object oriented programming, encapsulation, because all the pillars are related to encapsulation only. And just to give you the basic thing about that is, it conceals the internal state of object, restricting direct access to their data. And because of this, it promotes data security, prevents accidental modification, and it allows controlled access via methods. Although right now I can understand it becomes slightly difficult for you to absorb, but uh, uh, just I mean be there in this, and slowly everything will start coming into your mind. Then the second pillar is abstraction. It's a conceptual representation of an object that includes only its essential features while ignoring the irrelevant details. And it allows developers to focus on what an object does rather than how it does. Okay, so the most important thing in abstraction is we are interested in what the object is doing, and we are not interested in how the object is doing, and that part is called abstraction, because the internal details are hidden and the internal details are abstracted from the normal users. It facilitates high level design, reduces complexity for the normal developers, and it adds in creating a comprehensible model of the real world systems. Because for everything, if we are going in a detail, so it will become a problem for the developers. So whatever your task is, you should know your task, and you should be attentive on your task only. Don't bother about the other tasks, they will handle their task, and that is called the abstraction. For example, right now we are uh, okay, this example I'll give later on. So it achieved through access modifiers, as I said. So there are three modifiers. One is public, another is private, and another is protected. So the abstraction in Java is achieved through these modifiers, and it controls the visibility and encapsulates implementation details. Then what is a third pillar, students? It is a mechanism for creating a new class that inherit properties and behavior from an existing class. So there will be two concepts in that. One is a superclass and one is a base class. Basically, inheritance is for the reusability. So in many of the books of object oriented programming, this inheritance is with the name reusability. Okay, so they are both one and the same thing. So reusability is achieved in Java through inheritance. And inheritance, if you are learning, so there are few things. One is you need to understand what is a base class, and then you need to understand what is a super class also. Yes. And one keyword, always keep it in mind whenever you hear this word inheritance in Java, is the word extends. Okay, extend is a keyword in Java. So it supports the reuse of a code and establishment of a hierarchical relationship between the classes. Now the last pillar is the polymorphism. Okay, polymorphism. I'll give you a very thanks. So polymorphism, students, is composed of two words. The first word is poly, and the second one is morphism. So poly means many, and morphism means forms. Morphism means forms. So one line definition, if you like, it's for the polymorphism, it is one name, multiple forms. And the implication is that when you are saying polymorphism, the implication is that it will give you an ability. It will give the ability to the objects of different classes to be treated as a objects of common superclass. Common superclass. This concept we have to see through program. Then it achieved through method overriding, and it is allowing a subclass to provide its own implementation of a method defined in the superclass. And it enables dynamic method binding and the flexibility in the methods call based on the actual object type. So this is literally a very important, pillar. And one last thing I would say, okay, all the pillars, for example, these are the four pillars. So abstraction is based on encapsulation. Abstraction is based on encapsulation, and inheritance is based on encapsulation and abstraction. And polymorphism is based on inheritance as well as abstraction as well as encapsulation. So all the pillars are related. They are not like independent, they are related. And the beauty of a Java, a programming language, in just a very small program you would see the implementation of all the four pillars, all the four pillars. So let's start the very first pillar. And just one revision is, in Java, encapsulation is implemented through class and objects. Encapsulation is implemented through class and objects. So I'm starting the first pillar, encapsulation, and I'm going in a detail because this concept requires a lot of efforts to understand. And understanding the classes in Java, it requires different angles, okay, or it requires a different perspectives. So what we have done, students, we have divided into three parts. And the first part says that class is a user defined data type. This is the first view. So if you are standing and if you are trying to look at the classes in Java, so classes are very versatile concepts. Classes is a huge concept. So we cannot go in just one shot. We have to figure out how we are understanding the classes. So first way is, you can think classes as a user defined data type. Now you are very good in data types, so you can think that way also. Class is a user defined data type. Then the second part that we are going to study is, class is encapsulation of data and functions. So one way to understand is, class is basically encapsulation. And what is an encapsulation? It's a wrapping up. It's a wrapping. You are putting a data and functions into one capsule form, and that concept is referred as a encapsulation. Then the third, and again the equally important part, is that class also act as a blueprint. So there are three different ways to understand classes and objects in Java, and we'll go one by one, slowly in detail. We'll start from the first perspective. Class is a user defined data type. All right, to recall from the last sessions, there are two kinds of data type, students. So I'm connecting from the last sessions also, this thing. The one that we heavily use is primitive data types, or they are also known as inbuilt data types. Okay, like for example, we have seen in detail what is integer and what is float, and we have seen the other data types also. So they are primitive, meaning what? They are inbuilt. Again, meaning what? They are already defined by the the Java framework, and they are already defined by the compilers. So they are there in Java from day one. How many of them? How many inbuilt data types are there in Java? There are 8 inbuilt data types in Java. Then the other class of the data types, if you remember again from the last session, we have seen a string class. So a string class is a reference data type, and this reference data type, if you remember, you can go back to the previous session also. This reference data type, I said it is user defined, user defined. So we as a programmer, we as a developer, we are defining the data types. So class belongs to user defined data type, and classes that let you define custom data type or a data structures and it behaviors like student and car. But I'll take the previous example only. For example, you know, string. Okay, so we have seen in detail what is a string. So a string is what? If you want a very a raw definition of a string. So what is a string, students? A string is a sequence of characters. So you have H, you have E, you have L, and again you have O. So it's a sequence. It's a sequence of what? Characters, and you put it in double quote, and it will become what? A data type, or it will become what? Kind of a data structure also, a data structure also, but we'll call it a data type only. And what kind of a data type it is? It is user defined data type. It is a user defined data type. What can be the other user defined data type? Okay, like the string, can we have other data type also? Yes, we do have plenty of possibilities. For example, see this one. If you are trying to store the information of a student, in any application, how will you define a student? So a student is a combination of a name, roll number, and age. So if you have three things, so you can define a student also. Like a string. A string is a sequence of characters, but a student is a combination of what? Name, roll number, and age. Just for your information, it's not an integer, and it's not even a string, and it's not even a character. Rather, it is a combination of what? One, this is a string. It may be string, or it may be integer, or it is a double, or it is a float value. So you are defining student with three things. So what it will become? It will become what? A user defined data type. And for that, what is required in Java? You should have class concept in Java. Slowly it will come. I'll give you a few more examples also. Then a book. What is a book? How will you define a book if you are making an application related to a book? Book is a collection of three things once again: title, the author, and the important thing is ISBN, which is like a number, uniquely defines any book, in the universe. So book is a collection of title, author, and ISBN. Can we have other objects? Yes, we do have plenty of objects. See this car. A car is a combination of what? A model, year, and engine capacity. So we are taking three things in each a class. So in Java, the point is actually string is a user defined data type, student is a user defined data type, book is a user defined data type, and car is also a user defined data type. Then we can have other examples also. Plenty of examples are possible. We would see each and everything. Employee. Okay, employee is the most common class you would encounter in Java programming. So it's a combination of ID, employee ID, then you have name also, and then you have a salary also. Point, if you're dealing with, a 2D or a 3D kind of thing, or if you're dealing with, a geometry, point is defined by its X and Y coordinates in 2D space. Circle is defined by its radius and center point. And one very famous example that we'll go through is it's in our textbook only, the dog example. So how will you define a dog in terms of data types? In terms of user defined data types, by its breed, age, and name. So if you have three things: name of a dog, age of a dog, and its breed, so basically you can define a dog. Now next thing is what? Next thing is important actually, and here I'm trying to teach, and here I'm trying to give something in terms of a syntax. So in Java, if you are in a main program, how you create a string, there are two ways. That we learned in last session. Okay, but one of the a syntax that we have learned in last class, it was like this: you have to write a string, and then the object name, it's a class name, then you have to write object name str, then you have to use a new keyword, and again you have to write a string in a form of function. Everything will come, and in this function as a parameter, what you have to give? This hello. Okay, so that way object is going to be created. Why I'm putting this thing here? Because I want to differentiate between a user defined data type and inbuilt data type. Data type. So how many inbuilt data types are there? There are 8 inbuilt data types. One of them is integer. So if you are defining integer a, that is going to define, okay, inside Java, this is sufficient. And if you are trying to put a value, so how would you put a value? A is equal to 10. That's it. Similarly, you can define a float f, and then straight away you can write the value also 1.2, 1 1.2, and you have to give some kind of a literal also. So that's the definition of a what? Float. Character we have seen also in previous sessions. That way you can define. But what about those data types? They are inbuilt data type, and all of these data types, their values are stored on which data structure? Their values are stored on stack. So for example, a is equal to 10 is going to stored on stack, and f is going to stored 1.2 on stack. I hope everybody can recall and can connect to the previous sessions. But here is a different strategy, students. Whenever you are saying a new, so you are telling a Java, okay, this data type is a user defined data type, and you have to create this object on a different data structure. And can somebody recall it? This data structure is a heap data structure. So actual value is stored on heap. Actual value is stored on heap. Now, now, how can you create a student object? How can you create a student object? You have to follow the same, uh, the syntax. You have to follow the same syntax. So instead of a string, what you would write a student. Instead of a str, this is the object name, by the way, you have to write s1. And what about this new? This new keyword is telling us that this object or this data type actually is going to be stored, or actually it is going to be created on which data structure? It is going to be created on heap data structure. And instead of a hello world, how many values you have to pass? You have to pass 3 values: name, and then this is a roll number, which is also an integer, and this is the age of a student. So that way you can define a student. So syntax is pretty similar. Just the class name, the object name, new keyword, which is for the heap, and then this is a function. And just I'll give you, this is a special function, and it is known as constructor. Everything will come, but I'm just giving you from a perspective. Class is a user defined data type. Now everybody can understand, okay, how will you define a book, or how will you create a book object? Obviously there are 3 things which are required. One is the title, and another is author, and then ISBN numbers. You have to give 3 values. And how can you give a 3 values? Just by calling these 3 parameters, or just by calling this constructor and passing these 3 values. Structure is exactly same. Book b1 is equal to new book, and then these 3 things you have to pass. Then the fourth one is what? A car object. How can you create a car object? Exactly the same way. So what I'm expecting from your side, students, is now you can connect also. The first angle is that class is a user defined data type. Obviously, when it is a user defined data type, it will take some memory. And where it is going to take some memory, it's not an inbuilt data type, it's a user defined data type. So it is going to take a memory on something called heap data structure. Heap data structure. How you are going to create these objects? Very simple. The syntax is very simple. You have to give the class name, then the object name, the new keyword, and then you have to call the constructor. You have to call the constructor. And one last, employee also you can create. And now any kind of an object you can create. Dog, because uh, I have to take this example in this explanation. So I've created a dog object also. So where is the class? This is a class. This is the object name. Again, this new keyword is for heap data structure. And then these are the 3 values that we are taking inside the constructor. Inside the constructor. Now, I think we have understood the first perspective of a class. What is the first perspective, class is a user-defined data type. In many of the books, and I would say in most of the books, you will find the definition of a class in Java as class is a user-defined data type. But there is a second perspective also, students, and this perspective or this view says that class is an encapsulation of member and function. Member and function. What is a member? It's a data member that we are talking about. So it's a encapsulation of what? Data member plus member function. What are those? We have to understand. And what is encapsulation? That thing also we need to understand. So what is encapsulation? The word encapsulation has come from the word capsule. Capsule. So how many of you have heard about the word capsule? All of you. All of you have heard this word. So in medical science, or especially in pharmaceutical science, what is a capsule? So capsule is composed of many small medicines. For example, if you are taking, the multi vitamins capsules. So in just one unit, you can have B12, you can have B3, you can have B6. So small medicines that are put together in one module, and that thing is called what? A capsule. But a capsule is, students, is a generic word. It's not only related to a pharmaceutical science or medical science, it's a generic word. Anything if you are putting in kind of a box or in a kind of a capsule, that will become what? A capsule. I think many of you have heard about the capsule elevator also, especially in the malls and especially in the offices, you would see a capsule elevators. So those capsule elevators, they carry the people, they carry the the employees, they carry the students, and in mall they carry the customers from one floor to another floor. So that's a capsule elevator. Now in Java, especially in Java, the capsule is what? It's a capsule of variables. That means a data members plus method. So you define variable, I would say variable data members, and you also define functions related to that functions, and you put it in one module, and that module becomes what? A capsule. And this process is known as what? Encapsulation. So simple definition is wrapping of data, that means a member function, data members and functions in a confined area. And what is a confined area? It's a capsule. And this process is known as what? Encapsulation. So class encapsulates data and function into a single unit called capsule, or called a class itself. It is from the capital C and it is from the small c. And the process that how we are making these capsules, how we are putting these things in a capsule, it is known as what? Encapsulation. The examples I would see, the examples that you would see here is in actually a class, you will find different things. Okay, different terminologies are there, and please don't confuse yourself. Number one thing is variables, and when variable I say, it's data members I'm talking about. Then methods. So when I'm saying a method, so member functions I'm saying. Then there is a special kind of a member function which is known as a constructors. So mostly in all the classes you will find these three things. But in some cases, in rare cases, you may also find nested classes also. But that is, we are not going to see in the beginning. That we will see in later on in advanced topics. The class can contain classes also, but just for the time now you can focus on that. Class is an encapsulation of three things: variables plus methods plus constructor. The example I would give here is a dog, because I said, yeah, I have to take this dog example. What is the class name? The class name is dog. What are member methods? I think I made a mistake when I was typing. It's not a method, it's data member only. So you can write it here, rectify this: data member only. Data member. So how many data members are there? The dog class can have its breed, its size, it may have a color also, and it may have a age also, the dog class. And what about the functionality? What about the functionality? So dog can eat, dog can sleep, dog can play, and dog can make a sound also. make sound also. So if you are putting together in this unit or in this capsule form, it will become what? A class. It will become a class. Another example I would give you is of circle class. Circle class. So what is a circle class? Circle class, we can have a data member as radius, and this is a UML diagram. So this is a normal diagram and this is a UML diagram. uh, Purposely I've put it in a different way so you can represent a class like this also. What is a class name? It's a circle. And how many data fields are there in this? One data field is the radius. And how many methods are there? There are different methods. So these two are what? Constructors. And they get area, get parameter, and set radius. They are the normal methods, or you can call it a class methods. Class methods. So if you are putting all of these together in one capsule or in one unit, the process will become what? Encapsulation, because all of these things you are putting in one capsule form, one capsule form. And how you would write a code for that? Let me give you an example for this. How would you write code for that? Code, you will start from the keyword class, and this is a circle. This is a circle. And how would you define a member in that? Double radius, and this is a default value, and this is a constructor. This is a constructor, this is another constructor, and they are they are three different you can say methods and a class circle. So one is the get area, another is get parameter, and another is set radius. So these are the three different methods in that. Yes, what? Encapsulation. So let's quickly see the third angle also. Third angle also. And the third angle says that class is a blueprint. Class is a blueprint. So what is a blueprint? In civil engineering, before we start any construction, first, the civil engineers make the blueprint. For example, this is a blueprint of one bedroom flat. And some of you may get some idea how the flat is going to be. So similarly, in a very similar way, class act as a blueprint also. So when you are defining a class, students, when you are defining a class, it will give you a raw picture, or it will give you template, or it will give you the first understanding how the objects are going to be in the real world and how can we define the objects. So class is a blueprint. In other words, you can say the class is a template also. And once the blueprint is created, students, you can create as many as objects as you want. For example, if this blueprint is correct and it is passed, and the customer and the clients, they have accepted this blueprints, now from this you can create as many as objects, as many as objects. Similarly, if you have a class, for example, which class? Dog class itself. So you created this blueprint, and from this blueprint you can create as many as objects as you want, D1, D2, and D3. So just to give you a summary, there are four pillars in object-oriented programming. The first pillar is encapsulation. The second pillar is abstraction. The third pillar is inheritance, and the fourth pillar is what? Polymorphism. And in Java, the encapsulation part is implemented through what? Class and objects. And we can understand a class from a three different perspective. First perspective is literally very important, and it says that class is a user defined data type. The second perspective, it says that class encapsulates data member and member function into a single unit known as capsule. This process is known as encapsulation. And the third part, it says that class act as a blueprint also. Blueprint also. So once you make the blueprint, you can create as many as objects as you want. Thank you very much, students.